Welcome back, my dear students, to our next chemistry class. Last class we have discussed about classification of amines, nomenclature of amines and structure of amines. Now we are going to discuss about method of preparation of amines, properties of amines. First we are going to discuss about general methods of preparation of amines. In that many methods are there, both aliphatic amines and aromatic amines we are going to discuss. First method of preparation is nothing but from nitro compounds. You know nitro compound means what is the functional group for nitro? Bond NO2. Okay, so from nitro compounds. Okay, nitro compounds will undergo reduction in the presence of a catalyst like nickel, iron bar, HCl. It will give amino compounds as the product. So the example I have taken is nitroethane. Nitroethane. CH3 bond CH2 bond NO2. Nitroethane. So nitroethane will undergo reduction in the presence of nickel as a catalyst. What is meant by reduction? Addition of hydrogen. Okay. So in the presence of nickel or iron bar HCl, it will give what as the product? Amino compounds as the products. Okay. Instead of removal of, what is meant by reduction? Addition of hydrogen or removal of oxygen. So oxygen will be removed and hydrogen will be added. So you will get what as the product? Ethylamine or ethane amine as the product. Last class we have discussed about nomenclature of amino compounds, isn't it? Okay. So amino compounds, how we can name in common system and IUPAC system, both the system we have discussed. So the first method of preparation is nothing but from nitro compounds. So nitroethane will undergo reduction. It will give what? Nothing but ethylamine or ethane amine as the product. At the same time, from the same method, we are going to prepare what? Also aromatic amines also. Okay, so nitrobenzene will undergo reduction in the presence of platinum as a catalyst. Okay, and stannous bar hydrochloric acid as a catalyst, and it will give what as the product? Aniline as the product. What is the formula for aniline? C6H5 bond NH2. See, above the benzene ring, NH2 amino group is there, means the name of that compound in common system, aniline. Understood? Okay. So, nitrobenzene will undergo reduction in the presence of platinum and stannous bar hydrochloric acid. It will give what? Amino compounds as the product. That is nothing but aromatic amines like aniline. It will give as the product by the removal of water. Okay. The next method of preparation we are going to discuss is from nitriles. Cyanides and isocyanides. From nitriles means nothing but nitriles will undergo reduction. Nitriles means cyanides. Okay. So cyanides will undergo reduction. It will give amines as the product. At the same time, isocyanide will undergo reduction also. It will give what as the product? Amines as the product. But first one I have taken is methyl cyanide. What is the formula for methyl cyanide? CH3 bond Cn. It will undergo reduction. What is the meaning for reduction? Addition of hydrogen. In the presence of sodium amalgam. What is meant by amalgam? Mercury mixed with any metal, that is called as in what? Amalgam. So sodium mixed with mercury, it is called as in sodium amalgam. And in the presence of ethyl alcohol or otherwise lithium aluminum hydride. What is lithium aluminum hydride? It is a reducing agent, or reduction will be take place in the presence of a catalyst like nickel. Understood? So methyl cyanide CH3 bond Cn will undergo reduction in the presence of a catalyst like sodium amalgam, lithium aluminum hydride and nickel. It will give amino compounds as the product. Listen, see here, between carbon and nitrogen triple bond will be there, so that bond will be cleaved. Instead of that, 2 hydrogen will go and add to this carbon and another 2 hydrogen will go and add to this nitrogen, and you will get CH3 bond CH2 bond NH2. Okay, ethylamine as the product. Understood? Next one is what? Methyl isocyanide. What is the meaning for cyanide? Cn. That position will be changed, means then we can say that is a isocyanide. So methyl isocyanide means CH3 bond NC. Understood? NC. Cn cyanide, NC isocyanide. So this also will undergo reduction in the presence of sodium amalgam and ethyl alcohol. It will give what as the product? Means nothing but this is an example for secondary amine. Already we have discussed before this class. Primary amine means nitrogen can have 2 hydrogen atoms. So cyanide will undergo reduction, it will give what? Primary amine as the product. So methyl cyanide will undergo reduction, it will give what? Ethyl amine as the product. Isocyanide will undergo reduction, means it will give what as the product? Means secondary amine as the product. Secondary amine means with nitrogen only one hydrogen. With nitrogen only one hydrogen. So what will happen? Nothing but CH3 bond NC. Okay, with N one hydrogen, and with this C what? 3 hydrogen will come. Totally 4 hydrogen will be added, and 1 hydrogen with nitrogen and 3 hydrogen will with this carbon, and you will get CH3 bond NH bond CH3. Nothing but with this nitrogen. Okay, methyl group is added. So N-methyl. And what is this methyl? Nothing but methane amine. This is nothing but methane amine. What's the formula for methane amine? Last class we have discussed CH3 bond NH2. From methane amine, one hydrogen will be removed. Instead of that, another one methyl group is added. So name of this compound is N-methyl methane amine. N-methyl methane amine. Understood or not? Okay. The next method of preparation is nothing but from amides. From amides. What's the functional group for amide? Bond CONH2. What's the functional group for amide? Bond CONH2. So acetamide. CH3CONH2. Acetamide formula. What is the formula for acetamide? CH3 bond CO bond NH2. Acetamide will undergo. Understood? Reduction. That is nothing but reduction. What it will give as the product in the presence of lithium aluminium hydride. What it will give as the product means 2 hydrogen will be added with this oxygen, and it will be removed as a water molecule. It will be removed as a water molecule. Instead of removing this oxygen from this hydrogen, 2 hydrogen will be added to this carbon, and you will get CH3 bond CH2 bond NH2. Understood or not what I am saying? Okay. Acetamide. CH3 bond CO bond NH2. Acetamide will undergo reduction in the presence of lithium aluminium hydride by the removal of water molecule. Addition of hydrogen means what? That is nothing but reduction. So 2 hydrogen will be added with this oxygen, and it will be removed as a water molecule. And balance 2 hydrogen will go on attached to this carbon, and you will get CH3 bond CH2 bond NH2. Ethyl amine or ethane amine. Ethyl amine common name, ethane amine IUPAC name. Next reaction is nothing but Hoffman's degradation reaction. Already we have discussed this one in carboxylic acid lesson itself. Understood? Okay. Nothing but Hoffman's bromamide reaction. Okay, naming reaction. So amide, what is that amide? Functional group bond CONH2. So amide will undergo bromination in the presence of potassium hydroxide. It will give primary amine as the product. It will give what as the product? Primary amine as the product. So CH3CONH2 acetamide will undergo bromination with potassium hydroxide. It will give CH3 bond NH2 methylamine. Nothing but example for primary amine, and by the removal of K2CO3, potassium carbonate, potassium bromide and water molecule. Okay, so Hoffman's degradation reaction, Hoffman bromamide synthesis, otherwise we can say. So this is nothing but this Hoffman's bromamide reaction is used for the method of preparation of primary amine from amides. From amides. Next reaction is nothing but very important reaction. It is one of the naming reaction and mechanism also. Gabriel thalamide synthesis. Gabriel thalamide synthesis. That is nothing but alkyl halides. From alkyl halides. Under the topic we are going to discuss. Gabriel thalamide synthesis. Thalamide. Imide means between carbon and nitrogen bond is there, means then that is called as an imide. Thalamide. From phthalic acid we got this. So name of this compound is thalamide. Thalamide. Understood? Okay. So we are going to discuss Gabriel thalamide synthesis. Listen step by step. First, thalamide react with potassium hydroxide. Thalamide react with potassium hydroxide. Understood? This hydrogen and this OH will be removed as a water molecule. This hydrogen and this OH will be removed as a water molecule. Understood? Now what will happen? Balance this potassium K will come and attach to this nitrogen. So you will get what as the product? This is called phthalimide. Now instead of hydrogen, what will be there? Here potassium is there. So name of this compound is potassium phthalimide. Potassium phthalimide. This potassium phthalimide react with alkyl halide. What is the formula for alkyl halide? R bond X. Alkyl halide, R bond X. Now what will happen with this alkyl halide? Potassium phthalimide react means it will give what as the product, and what will be removed means this K and this X will be removed as KX, potassium halide. Potassium halide. Okay, balance what will be there here? Or alkyl group is there. So that alkyl group will come and attach to this nitrogen, and you will get like this way as the product. Now this is called potassium phthalimide and this is called alkyl phthalimide. What is that? Alkyl phthalimide. Now again this alkyl phthalimide combined with 2 molecules of potassium hydroxide. 2 molecules of potassium hydroxide. Totally here 2 OK is there and 2 hydrogen is there. So this 2 hydrogen will go and attach to this Rn and it will be removed as R bond NH2, primary amine. Balance 2 OK will go and attach to this C double bond O and C double bond O, and it will give what? Like this way, salt like product, nothing but potassium salt of phthalic acid, or it is called as potassium phthalate. It is called as potassium phthalate. Understood or not what I am saying? So it is one of the best method of preparation of primary amine from phthalimide. So name of this reaction is called as in Gabriel phthalimide synthesis. Understood? Okay. Once again I will repeat this one. Phthalimide combined with 1 molecule of potassium hydroxide. By the removal of water molecule, potassium will go and attach to this nitrogen and it will give what? Potassium phthalimide as the product. This potassium phthalimide react with alkyl halide. This potassium and halide will be removed as a potassium halide KX, and this R will come and attach to this nitrogen and it will give what? Alkyl phthalimide. This alkyl phthalimide again react with 2 molecules of potassium hydroxide and 2 hydrogen, 2 OK will be there. So this 2 hydrogen will go and attach to this R bond N and it will be removed as a primary amine, R bond NH2. Balance with this 2 carbon, 2 OK will go and attach to this and it will give what as the product? Potassium phthalate as the product. Okay, the next reaction is Hoffman's ammonolysis. What is meant by ammonolysis? Addition of ammonia. Addition of ammonia. Now we are going to, we are discussing the method of preparation of amines from alkyl halides. Under the topic we are discussing. So now alkyl halide will undergo ammonolysis. First step. Okay, from alkyl halide. So first 1 molecule of alkyl halide combined with ammonia. That's why it is called as an addition of ammonia is called as an ammonolysis. So methyl bromide. Alkyl halide example what I have taken? CH3Br, methyl bromide combined with ammonia. By the removal of here this 1 hydrogen and 1 hydrogen and this Br will be removed as an HBr, hydrogen bromide. Balance what will be there? 1 hydrogen will be removed means NH2. This NH2 will come and attach to the CH3. You will get like this way CH3 bond NH2 methyl amine. It is an example for primary amine. It is an example for primary amine. Okay. Next, this after getting this primary amine, again it will be combined with another 1 molecule of methyl bromide. Another 1 molecule of methyl bromide. Again what will happen? This hydrogen, 1 hydrogen and this Br will be removed as a HBr. Okay, what will happen after that? Instead of removing 1 hydrogen, this methyl group will come and attach to this nitrogen. So you will get CH3 twice NH. NH2 means primary amine. Nitrogen can have 2 hydrogen atom, primary amine. Nitrogen can have 1 hydrogen atom, that is a secondary amine. So CH3 twice NH. You are getting what as the product? Secondary amine. Again this secondary amine react with another 1 molecule of methyl bromide, alkyl halide. alkyl halide like methyl bromide, another one molecule, it will be combined, means what will happen finally? This one hydrogen also combined with this Br and it will be removed as in what? HBr. And this CH3 also will come and attach to this nitrogen. So it will give what as the product? CH3 thrice N tertiary amine as the product. After that, this tertiary amine combined with another one molecule of methyl bromide. Another one molecule of methyl bromide. You know ammonia means NH3. What is the formula will come for ammonium? NH4. Okay, now another one molecule of methyl bromide combined means what will happen? Is there any hydrogen with nitrogen atom in tertiary amine? No. So here hydrogen and Br will not be removed as a HBr. So what will happen? Instead of that, just this CH3 will go and attach. So it will become CH3 4 times. Already nitrogen is there. So it will become positive and Br minus. So it is nothing but what they are saying? Quaternary ammonium salts. Quaternary ammonium salts. Quaternary means 4. Ammonium means 4. NH4. Instead of removing all the 4 hydrogen from ammonium ion, NH4 plus. Instead of removing all the 4 hydrogen from ammonium ion. What is ammonium ion? NH4 plus. So what will happen? All the 4 hydrogen will be replaced by 4 methyl group. Understood? Okay. Okay. So what is this? This is called as an quaternary ammonium salt. Both plus and minus. So it is called as an, it is nothing but like a salt-like product. Understood? So quaternary ammonium salt, it will give us the product. So with one molecule of methyl bromide, if you are, that is will combine with ammonia, it will give primary amine. Primary amine combined with another one molecule of methyl bromide, it will give secondary amine. Again that secondary amine react with another one molecule of alkyl halide like methyl bromide, it will give tertiary amine. Again tertiary amine combined with another one molecule of alkyl halide like methyl bromide, it will give finally salt like product, that is nothing but quaternary ammonium salt as the product. The next one is nothing but from alkyl halide, but alkyl halide combined with sodium azide. Sodium azide, sodium Na, azide means N3. So NaN3 is the formula for sodium azide. So methyl bromide combined with sodium azide, what will happen, you know? Okay, this Br and this Na will be removed as an NaBr. Understood? This Na and this Br will be removed as an NaBr. Then next what will happen? This N3 will come and attach to this methyl group and you will get methyl azide as the product. That is nothing but CH3N3 methyl azide. This methyl azide will undergo what they are saying? Reduction. What's the meaning for reduction? Addition of hydrogen. So with one nitrogen, 2 hydrogen will be added. So you will get the final product is methyl amine. Nothing but what? Primary amine. Name of this compound in IUPAC system, methane amine. And balance 2 nitrogen is there, that will be removed as N2. That will be removed as N2. Okay. The next one is nothing but chlorobenzene. Chlorobenzene will undergo ammonolysis. Nothing but with chlorobenzene, if you add ammonia NH3 in the presence of what? Cu2O. What is Cu2O? Cuprous oxide at 200 degrees Celsius. What will happen? One hydrogen and one Cl will be removed as an HCl. Balance this NH2 will be there. That NH2 will come and attach to this C6H5. So it will give what? C6H5 bond NH2, aniline as the product. Aniline as the product. Understood or not? Okay. Next one, ammonolysis of hydroxyl compounds. Hydroxyl compound means OH group will be there. Means then we can say that is a hydroxyl compound. So alcohol. Alcohol like ethyl alcohol will undergo ammonolysis. Addition of ammonia is called ammonolysis. So alcohol like ethyl alcohol combined with ammonia in the presence of aluminium oxide Al2O3, OH and H will be removed as a H2O. Then balance here NH2 will be there. That NH2 will come and attach to this ethyl group and you will get ethyl amine, nothing but primary amine as the product. Again this primary amine combined with another one molecule of hydroxyl compound like alcohol. Again OH and this H will be removed as a water molecule and you will get what as the product? Secondary amine C2H5 twice NH as the product. Okay. Again this secondary amine combined with another one molecule of ethyl alcohol. Okay. So same way that this hydrogen and this OH will be removed as a water molecule and you will get what as the product? Tertiary amine as the product. Okay, so hydroxyl compounds will undergo ammonolysis also. You will get what? Primary amine, secondary amine and tertiary amine as the product. The next one is nothing but phenol will undergo ammonolysis in the presence of anhydrous zinc chloride. Anhydrous zinc chloride. What is the formula for phenol? Above the benzene ring, OH group is there, means we can say that is a phenol. Okay, so formula for phenol is C6H5OH. Phenol combined with ammonia. From phenol OH and from ammonia one hydrogen will be removed as a water molecule and you will get C6H5 bond NH2 aniline as the product. So this is also one of the method of preparation of amines. Okay. Physical properties of amines. Next one we are going to discuss about physical properties of amines. Under that, carbon. Amines can have less number of carbon atom like 1 carbon, 2 carbon. Amino compounds are colorless and ammonia like smell it can have. With less number of carbon atom, amines can have like 1 carbon and 2 carbon compounds are colorless and ammonia like smell. And the amines can have 4 or more carbon atoms or volatile liquids with fizzy odor. Boiling point about amines we will discuss means what is that? Because of presence of polar nature or because of polar nature of primary and secondary amines, it can form intermolecular hydrogen bond by using the lone pair of electron present on nitrogen. But tertiary amine cannot form such type of hydrogen bonds. So, boiling point among primary, secondary and tertiary amine we will take means primary amines boiling point is more than that of secondary amines than that of tertiary amines. So between or among amines like this way only hydrogen bonding is occur. Dotted line is nothing but hydrogen bond. This is one amino compound, this is another one and this is another. Between these three, okay, from this amines hydrogen and this nitrogen, okay, will be formed as hydrogen bond. Same way this hydrogen and this nitrogen between that hydrogen bond. What is meant by hydrogen bonds? Hydrogen atom is bonded to electronegative, highly electronegative elements like nitrogen, oxygen and fluorine. Hydrogen atom combined means with these three elements, then we can say there is a hydrogen bond. So in amino compounds or between the amino compounds, hydrogen and nitrogen between that bond is formed. So this is an example for hydrogen bond. What is meant by intermolecular hydrogen bond? Between the two molecules or more than two molecules. The two molecules or more than two molecules may be same or different. Between that hydrogen bond occur means then that is called as an intermolecular hydrogen bonds. Okay. So due to the presence of or polar nature of primary and secondary amine. So primary and secondary amines can form intermolecular hydrogen bond because of presence of lone pair of electron and nitrogen atom, but in tertiary amine no such type of hydrogen bonds and are formed. So compared to primary, secondary and tertiary amine boiling point, Primary amines more than that of secondary than that of tertiary. But compared to alcohols, amino compounds can have less boiling point or lower boiling point compared to alcohols. Because in alcohols, between hydrogen and oxygen bond formation is there, and in amines between hydrogen and nitrogen bond formation is there. Compared to nitrogen, oxygen is highly electronegative. Nitrogen electronegative is less than that of oxygen electronegative. So, between nitrogen and hydrogen bond is what they are saying, less than that of what value? Between the oxygen and hydrogen bond value. So, alcohols are nothing but alcohols means what? Bond OH. So, alcohols are higher boiling point than that of amines. The next point is solubility. Solubility means whether it will be amines will be soluble in water or not, that only. So lower member with 2 carbon, 3 carbon, 1 carbon, that is called as a lower member of amines. So lower aliphatic amines are soluble in water. But higher members are insoluble in water. That is nothing but increase of molecular weight. Higher members means what will happen? Alkyl group will be more like that way. Say example, lower aliphatic amines, if you take example CH3 bond NH2. CH3 bond CH2 bond NH2. CH3 bond CH2 bond CH2 bond NH2. So like that way, the hydrophobic alkyl group will be increased, means molecular weight also will be increases, and that hydrophobic alkyl group will not be leave to dissolve amines in water. So automatically what will happen? Increase of molecular weight means solubility will be decreases. Because of what? Hydrophobic alkyl group present in the higher member of amino compounds. Okay. Next, chemical properties of amines. Amines are generally basic in nature because of presence of lone pair of electron on nitrogen atom. So basic in nature means what will happen? It will be combine or react with acid. It will form salt-like product. So amines are basic in nature. Example, aniline combined with hydrochloric acid. It will form salt-like product CCH5 bond NH3 plus Cl. Next, we are going to discuss about basic strength of amines. What is the basic strength of amines? Already we have discussed in carboxylic acid lesson, acid strength of carboxylic acid, acid strength. Okay. Now, this amines dissolved in water, it will form what? R bond NH3 plus and OH minus. This is an equilibrium reaction. How we can write for this equilibrium reaction? Constant. Nothing but product of product divided by product of reactant. So basicity constant Kb is equal to, how we can write? R bond NH3 plus into OH minus divided by R bond NH2, and water also will come. But water is what? Excess. Water concentration is excess. So that will be a constant. So no need of taking and writing here water. So this is what? Nothing but basicity constant. Suppose this basicity constant will be higher, basicity constant value will be higher, then basic strength of that amines also higher. But what will happen? pKb will become a lowest. Understand that? Already we have discussed in carboxylic acid lesson itself for Ka, for acid Ka. What is that? Acidity constant. Now, amines are basic in nature. So, for this, what we are finding? Basic strength of amines. So, we are finding what? Basicity constant. Basicity constant, this value will be more, means what about that amines basic strength also will be higher. But what about the pKb value will be lower. Okay, understood? Next questions for your assignment. Explain. There are 2 questions I have given, children. One is explain the methods of preparation of amines. Both aliphatic amines and aromatic amines, both the method of preparation they have given. Now we have discussed. Okay. And the second question is write a note on physical properties of amines. Physical properties of amines, nothing but physical state, whether it is a colorless liquid or solid or like that way, and then boiling point and solubility. This and all will come under physical properties of amines. So these are the questions you have to write and send the assignment to my number.